Okay, let's talk about something that's totally hidden in pretty much every concrete building, but can literally mean the difference between a solid structure and a total disaster. We're diving into steel lapping and why it's the weakest link you absolutely need to know about.
So let me ask you a question. When you look at a massive skyscraper, what do you think is its weakest point? I bet it's not what you'd expect. It's not some huge beam or a giant column. Nope. It's a tiny, almost invisible detail that either holds the whole thing together or lets it all fall apart.
But before we can really get into that weakness, we've got to understand the strength behind it. So let's kick things off with the role of reinforcement.
So, you know concrete, right? It's amazing at handling being squeezed, that's compression, but it's just awful at being pulled apart, which is called tensile strength. To solve that, we embed steel bars, or rebar, inside it. Simple enough. But here's the catch. Those steel bars don't come in infinitely long pieces. So what do you do when one bar ends and you need to keep going?
Exactly. How do we create one continuous line of strength from a bunch of shorter pieces? Well, it all comes down to a really critical handoff. It's all about transferring the load.
And the technique we use is called steel lapping. It sounds technical, but it's actually a pretty simple idea. You just overlap two bars for a certain distance. That overlap creates a continuous path for all those forces to travel, basically tricking a bunch of short bars into acting like one single unbroken piece of steel.
Now here's where it gets really cool. How does that force actually jump from one bar to the next? Think of it like a relay race. The force, that's the baton, is running down the first steel bar. Then, in that overlap zone, it gets handed off through the concrete to the second bar, and the second bar takes off with it. So you see, the concrete isn't just filler here. It's the actual medium for this critical handoff. It's got to be strong.
And this quote just nails it. The whole point is to create structural continuity. It's kind of an engineering illusion, right? But it's an illusion that provides very, very real strength. You know, life-saving strength when it's done correctly.
So that's how it's supposed to work. But what happens when that link breaks? Let's look at the most common and frankly scariest failure points.
The biggest, most dangerous mistake you can make is getting the lap length wrong. If that overlap is too short, the force just can't make the jump. It doesn't get fully transferred. You've essentially designed a weak spot right into the structure from day one. Having sufficient length isn't just a good idea, it is absolutely non-negotiable.
But it's not just about how long the lap is, it's about where it is. If you put all your laps in the same spot, especially in a high-stress area, you're creating what's called a plane of weakness. It's like you're creating a perforated tear-here line right through the concrete. The smart way, the right way, is to stagger those laps. Spread them out in areas with lower stress. That way, the structure stays strong and whole.
And then you've got this really practical on-site problem, reinforcement congestion. It's basically a traffic jam of rebar. When you cram too many laps and bars into one little area, the wet concrete can't flow in and around the steel properly. This creates empty pockets or voids, and that completely ruins the bond between the steel and the concrete. And remember, that bond is everything. It's what allows the load transfer to happen in the first place.
Okay, enough of the doom and gloom. We know the problems. So how do we get it right every single time? Let's look at the blueprint for success. It's all about forging that stronger bond. So here's your playbook. This isn't just a checklist. It's a code for structural integrity. First, you have to nail the correct lap length according to the design codes. No shortcuts. Second, stagger those lap locations. Never ever create that plane of weakness. Third, make sure you have proper spacing so that concrete can get in there and wrap around every single bar. And finally, just avoid congestion altogether. These 4 rules, they are your foundation.
So, why are we focusing so much on this one tiny detail? Well, because this detail is, quite literally, the foundation of safety. Let's really hammer home why this matters so much.
100%. That's the goal for every single lap. Not 99%, 100. We need a complete 100% transfer of force from one bar to the next. Anything less, and you're introducing a failure point into the system. Period.
And that leads to the ultimate takeaway here. A structure is only as strong as its weakest link. It doesn't matter if every other part of the building is perfect. One single failed lap, one broken link in that invisible chain of steel, can compromise the entire structure, the entire thing. So, we'll leave you with this. The true integrity, the real strength of a structure
is hidden in the details you can no longer see once the concrete is poured. And the real question for every single person involved in building it is, are you looking close enough?